Hello student, welcome to VidyaNest. You have come to know that already we have started permutation and combination. Last day the definition of permutation without repetition was taught, and today we will proceed something more on it with the basic of combination. See, last day we got the concept of permutation if repetition not allowed. Repetition not allowed means, suppose there are r number of r rows and n elements n elements. So n elements. Now permutation combination is being started last day, and today we are continuing with more concept. You keep and watch. If anywhere if you find any difficulties, without any hesitation you ask. Okay. So last day we had gone through this concept that if n elements are arranged in r rows, if repetition not allowed, means once you choose one element, that element cannot be used again. So in this way you got the total arrangement in this way, npr n minus r factorial. But today I am telling you, if repetition allowed, what happens in that case? That means suppose first element is chosen to fill up the first row. But in that case, in the previous case where repetition not allowed, then if you choose one element, then number of elements would be reduced by 1. But right now, and repetition allowed, that means once you choose this element, then you have to return it, because you will have to use it again. That means the first row can be filled up by n ways. In previous case where repetition was not allowed, then once the first element occupies the first place, then n minus 1 elements were waiting for occupying the second. But this time the element which you are calling, you are returning back. That means total number of elements is not being reduced. So for the second elements also, I can choose same number of, from second row also I can choose same number of elements in n ways. N ways. Repetition allowed means once you use one element out of n, then you will be allowed to use it again. Now first two rows can be filled up. First two rows can be filled up by n into n ways, which you got in last case n into n minus 1 ways. So the element which is chosen to occupy to fill up the second row will be returned back again, so that the total number of elements will not be reduced. So still n elements is there, and third row can be filled up again by third row can be filled up again by n ways. So first three rows can be filled up by n into n ways. In this way, keep on filling the rows. How many rows are there? r number of rows are there. So keep on filling in this way. First r rows can be filled up by n n n r times. Had it been 3 times, it was n cube. So in case of r times, n to the power r, n to the power r. So in this case, for if repetition allowed, if repetition allowed, then total permutation or arrangements n to the power r, n to the power r. For one example, suppose one football match is on. 3 football match in a consecutive row. Total outcome win, loss, draw. So each outcome can be occurred with each match. So n to the power r, n is also 3 and r is also 3. In that case, n to the power r 3 cube. If total 27 ways. So if 3 football matches are on, how many result I can expect? 27 result. Okay, using this concept. So this is the arrangement or permutation in case of repetition allowed. Now, what is cyclic permutation? Cyclic permutation means you are taught in history about round table conference. So round table conference. So when few persons are sitting around a table, then the total number arrangement will give you the concept of circular permutation. Circular permutation in other way or in shortcut way we will remember. Suppose there is a line. There is a line here. 5 persons are sitting. 1, 2, 3, 4, 5. There is a bench in a park where 5 persons are sitting. Now, one thing is happened that horizontal bench, horizontal or straight bench is bent to form a circular table. If you bend it and form a table, the first and last one will coincide. Yes or no? Suppose there is a chair in the chair in which you are sitting in school. If the chair is bent and it is made in terms of a circular chair, then the first and last position will coincide. So in a linear arrangement which was seen to us factorial 5, now it will be reduced to 5 minus 1 factorial. Why? Because first and last position will fall on each other or coincide with each other. Okay. So in cyclic permutation, total number of arrangements will be n minus 1 factorial if n elements are there. If n elements are there. So what type of question you can expect from this portion? See, so in a round table, or in how many ways, in how many ways 7 men and 7 women can sit around a round table so that no two women can sit together. So it is one kind of riddles type question. So when it will be possible, if between two women, if I put one man, then two women will never be together. Yes or no?
Yes, sir.
So in round table, first we will fix 7 women. W1, 7 women. Now you observe that 7 women, when placed in symmetry around the table, then how many empty spaces between them so formed? How many empty spaces? Let us count. 1, 2, 3, 4, 5, 6, 7. Okay. So between 7 women, there are 7 empty spaces. Okay. Now, if I insert that 7 men in that empty spaces, then no women will sit together, because in that case between two women there will be one man. So actually, so between 7 women there are 7 empty space. There are 7 empty space in which if 7 men are told to sit, then no two women will sit together. So you have to follow that logic. Now in that 7 empty space, 7 men can be put in factorial 7 ways. So in that in that 7 empty space, 7 men can be put into factorial 7 ways. Now the question is this the answer? No, because that the position of the women are not fixed. This woman who occupies this position can exchange the position with this woman. So the position of the women will be changed. How? Then it will follow that cyclic permutation. Okay, 7 women can change their position in 7 minus 1 factorial ways. So these 7 factorial 7 number of ways will repeat 7 minus 1 factorial 1 times. Why? Because had the position of the women been fixed, then that would be the answer. But as the position of the women are not fixed, that means each of these factorial 7 ways will have arrangement with each position of these women. Okay, so 7, could you follow this? That this in factorial 7 ways I can arrange the boys, means men. But what about the women? Can women be fixed? Their position be fixed? No, not mentioned in the question. So that their position will be changed in what manner? 7 minus 1 factorial. So each of these factorial 7 will have uh, will have a correction with all these arrangement of the women. Understand? So 7 women can be arranged in 7 minus 1 factorial, that is factorial 6 ways. So each of these factorial 6 ways arrangements of women are connected by factorial 7 number of ways of men's arrangement. So total arrangements will be, I have told you that each of these factorial 6 ways arrangement of women have correction with each of factorial 7 number of ways of men's arrangement. So by unitary method you can get total arrangement will be factorial 6 into factorial 7. This is the concept of cyclic or circular permutation. Okay. Hope there is no problem. You have got it. What I mean to say. Yes. Yes. See that 7 factorial. How many women are there? 7 women. So in between them, how many empty spaces are there? 7. So in that empty spaces, I can, if I put 7 men, then no 2 women will sit together. Because why? Suppose here I have put 1 man. That means these 2 women are not clubbed together because there is 1 man lies inside them. Yes or no? So how many ways I can put? How many ways I can put these men in factorial 7 ways? Yes or no? Okay. Factorial 7 plus 7 men. So by definition of permutation, 7p7 npr. Okay, means this men can come here. M1, M2 can come here, M3 can come here, M4, M5, M6, M7. Now you can reshuffle. M2 can go there, M3 can come here, M4 can go there, M5 can go there. In this way, how many ways we can reshuffle the position of number men in 7p7 ways. 7 plus NPR. In elements are a number of places. 7%, 7 places. Okay, 7p7. Understand? 7p7. That means factorial 7. 7 minus 7. That is factorial 7 by factorial 0. Factorial 0 by default 1. So it is factorial 7 ways. Maximum student get confused here where we have multiplied it by factorial 6. Why I am multiplying? Because see that factorial 7 arrangement of men will clubbed with total number of arrangement of the women. Suppose this is one arrangement W1, W2, W3, W4, W5, W6, W7. So with this arrangement I can insert factorial 7 ways the total number of men. Now if you change the position of the women, because women's position is not fixed, another way W2, W3, W4, W5 in this way. With that arrangement also I have had factorial 7 number of men. Okay, means factorial 7 number of arrangement of the men. If you call W4 to occupy this place, W1 to occupy this place, W6 to occupy this place. In this, with that arrangement also, factorial 7 number of arrangement of men will be possible. So in this way, how women will be changed their position in how many ways? Factorial 6 ways. Yes or no? So with each of these factorial 6 ways, there will be factorial 7 number of arrangements. So total arrangement. See, with one arrangement of women, there is factorial 7 number of arrangement of men. So by unitary method, with factorial 6 number of position of women, there will be factorial 6 into factorial 7 number of ways. Understand? So there is the problem. Students sometimes put addition, sometimes they leave this, the sum at this position without considering the position of the women. Because had the position of the women be fixed, suppose instead of women, if I put 7 number of statue, then that would be the answer, because statue's position that is fixed. Or if women, that women position of the women will be fixed if it is mentioned in the sum, then only one way I can arrange the women. With one way, there will be factorial 7 number of ways of arrangement of men. So in that case, I would have not multiplied the factorial 7 with factorial 6. But here, woman's position is not fixed. Woman's position can be arranged in factorial 6 ways. So with each of these factorial 6, there are arrangements of men in factorial 7 ways. Total arrangement, factorial 6 into factorial 7. Okay. Now you have got it, understood little bit. See, suppose you have 3 elements A, A, B, C. You have had 3 elements. So how many total number of arrangement of this element is what? Total number of arrangements, factorial 3. You know that is exclamatory sign. That is permutation. That is permutation. 3p3 or factorial 3. Either you can say 3p3 or factorial 3. Now, you observe, if you are told to choose the element in pairwise, like AB, BC, CA, then pairwise or group-wise, then total arrangement, then number of arrangements, how many? 1, 2, 3. Yes or no? 3. But with each arrangement, there will be factorial 2 number of inner arrangement. Why? A can go there, B can come here. B can go there, C can come here. So, with each of these 3 arrangements, there exist factorial 2 number of arrangements arrangements internally. So, total arrangement with each of these 3 elements. See, with this arrangement factorial 2, this arrangement factorial 2, this arrangement factorial 2. So, total number of arrangements with each of these 3, there is this factorial 2 number of arrangement, that means 3 into factorial 2. Now the question is, here randomly I arranged and I got factorial 3. Here I group-wise arrange, I got the same if I consider the total arrangement. Means 3 into 2, 6. There, that is also 3 into 2 into 1, 6. So, that we can equate them. Therefore, 3 into factorial 2 3 into factorial factorial 2 is equal to that factorial 3. You can say, okay, that is so simple, all of us know that. But from here, one new concept is inherited. What? 3 is what? The 3 is, you know, number of new term combination. Factorial 2 means total arrangements in each combination, and factorial 3 means permutation. So we have got a relation between combination and permutation. Suppose if you drag the concept in your life, suppose you are studying in a school, there are 1,000 students in the school. It is very difficult to keep all the data of the school in a register or file. So the school is split into 10 classes and 30 section. Okay, so if 30 section means 30 group or 50 group, each group contains 20 students, means each class contains 20 students. Understand? So if you multiply each class's students total arrangement with the number of classes, you will get the total number of students arrangement. Understand? So, got it? So, from here, what conclusion I can draw? See, let there exist x number of combination, and with each combination there are factorial r arrangements, inner arrangements. So total number of arrangements x into factorial r, and that is nothing but, I told you, permutation. Now x is what? Number of combination. So that is in place of x, number of combination, number of group. Okay, number of group. In a class, for practical, some group are made. In each group contains 3 students. The total arrangement, suppose 30 groups are made. In a class, there is 90 students, 30 student, 30 group. Each group contains 3 elements, 30 into factorial 3. The number of combination is x into factorial r. What is permutation? NPR. So number of combination means NCR now. New NCR. Choosing R elements out of N group wise. Permutation means choosing R elements out of N randomly. It is group wise into factorial R. And NPR is what? that formula which already in the first class we have derived. So NCR factorial n by n minus r into factorial r. That is the relation between combination and permutation. Hope you could follow. Okay. Now you can ask me, what is the use of establishing this formula? Do we have any use of this concept? Obviously, the direct formula, from direct formula you can get some in JEE entrance even. Okay, not only in JEE main but even in advance. We will discuss in short while. See, from here 2-3 result we can derive. What result? In later, in when you will be taught binomial, that result will have deep relation to that chapter. So we have got NCR factorial n by n minus r into factorial r. Now NC in place of r, if I write r minus 1, r is replaced by r minus 1, so I can write so all r is replaced by r minus 1. Now you remove the internal brackets. Now add. You can ask me why you are adding? Just spending time? No. We are going to establish one important property from which you can get expect in the sum in JEE, and obviously it is deep. It has deep relation to binomial. So let us add this. NCR minus 1 factorial n minus r factorial plus this. Now in OpenEye, what is seem to us common? Factorial n. I can take common. If I take factorial n common, what will be left in the bracket? N minus r factorial r, n minus r plus 1 factorial into r minus 1 factorial. Now how we can simplify it more? We know, say factorial 5. Factorial 5 means 5 into its preceding numbers factorial. 5 into factorial 4. Now tell me, out of n minus r or n minus r plus 1, which is bigger? N minus r is bigger or n minus r plus 1 is bigger? Good. So n minus r plus 1 can be reduced by factor. Means factorial 5, if reduced by 5 into its preceding consecutive natural numbers factorial. So here n minus r plus 1 can be written as n minus r plus 1 into n minus r factorial. So you drag this value and put here. Factorial n minus r, and here you can write n minus r plus 1 into n minus r factorial, and this is r minus 1 factorial. Now what about this factorial r? Which is bigger, r or r minus 1? Obviously r is bigger. So factorial r can be splitted to its preceding factors. R into factorial r minus 1. So instead of r, you can write r minus 1 factorial. Now, if you observe carefully, what terms we can take common? See, n minus factorial r I can take common, and r minus 1 factorial I can take common, and that will give us what? See, that will give us, if I take n minus r factorial n by n minus r factorial I have taken common, and factorial r minus 1 I have taken common, what will be left in the bracket? 1 by r plus 1 by n minus r plus 1. Okay? Up to this stage, okay? So, we have nothing but to take the LCM. Factorial n take the LCM. R cancel. Now, if I write 5 into factorial 4 means factorial 5, then in numerator n plus 1 into factorial n will be n plus 1 factorial. So, in numerator I can write n plus 1 factorial. Similarly, you see r into r minus 1 factorial r. So, r into r minus 1 factorial r, this into this. So, I can rewrite this n plus 1 here. So, to observe, we persuaded from where? From NCR plus NCR minus 1, and after prolonged simplification, we have got this result. So, what conclusion I can draw? Therefore, NCR minus 1 is equal to n plus C1. Important result that is. That means 5C2 plus 5C1 is equal to 6C2. Okay. 5CR plus 5C2 minus 1 is equal to 5 plus 1 C2. Okay. Now, another property based on this, NCR by NCR minus 1. See, NCR means factorial n minus r factorial. Now you have got the flavor how to simplify. Factorial n minus r minus 1 factorial r minus 1 factorial. Now from here I can cancel factorial n. By the rule of division, this will go up. N minus, if I remove the inner brackets, n minus r plus 1 factorial by r minus 1 factorial divided by, again that concept which you have few minutes back consumed, that this number is bigger, so I can factorize it by reducing to its preceding consecutive factor. This number is bigger than this, so I can write n minus r plus 1 into n minus r factorial by factorial n minus r into r minus 1 factorial by r into r minus 1 factorial. Cancel, cancel. You have got a new result, n minus r plus 1 by r. So NCR by NCR minus 1 is equal to n minus 1, r plus 1 by r. Suppose you have got 5C3 by 5C2. Now that denominator suffix 2 can be written as 5C3 minus 1. Obeying that rule, 5 minus 3 plus 1 by 3, 6, answer 1. So without expanding into formula, if I know this, then in short span we can get the numerical answer. Okay, got it? Now we have got NCR. No matter, it is so simple to memorize this formula now. Now instead of R, you are replacing n minus r. So what changes will occur in the formula? Numerator, there will be no change. In denominator, in place of r, you have to put what? That n minus r. In place of r, n minus r. Now remove the bracket. Factorial n, factorial r. So we got stunned that even after manipulating in this way, the result remains same. So that is NCR. So we have got with the conclusion NCR is equal to NCN minus R. Suppose you have got 10C3, it means 10C10 minus 3 means 10C7. Understand? Now, little bit monotonous this proof work, but see, we cannot avoid. For example, I am referring one question. Let's see. If is equal to, then n satisfies the equation option A, Four options are given. It came in JEE Main 2016. So simple sum came in 2016. So students have obsession that okay, JEE is so tough, JEE is above our reach. No, not at all. The direct approach of formula, NCR and NPR we have. So our job is to simplify it. How? Let's start. NCR formula, if you forget at the beginning, you start with the sum, seeing the formula once. Okay, NPR, my suggestion, you don't learn, don't mark the formula. You make one formula chart, because there are so many formulas. When we'll be at the end session of syllabus, then so many formulas will come, and it is a tentacles of octopus like that will sap you. Hardly you can memorize. So if you can make a chart of formula, and if you see every day, so it will become the part of your DNA. Understand? NPR is this. So direct use the formula. Here n plus 2 CS NCR factorial n plus 2 n plus 2 minus 6 factorial into factorial 6 in denominator. NPR sorry, that is equal to 11. Now so simplification, by simplification we can reach up to this stage. And what seems to us common factor n minus 4 factorial, which we can cancel, by the rule of division. I can cancel it out. Okay. What would be the next? See, carefully you have to proceed. N plus 2 by division rule, I can write n plus 2 factorial by n minus 2 factorial into factorial 6 is equal to 11. Now, how to simplify it? How to simplify it? You observe n plus 2 is previous term, n plus 1 is previous term, n previous term, n minus 1, and is equal to 11. I can cancel n minus 2 factorial. Yes or no? Now, the question is, shall we multiply this? So big thing will come. So what will be the role of us? So big term is coming now. So we neglected the sum, but see, it deserves something more. Now what will be the next step? See, carefully you have to proceed. We have no other way but multiply. But before multiplying with flat removal of bracket, let us cross multiply this factorial c and see the outcome. Here we have to show some maturity, because if I multiply, there will be a huge 4th degree polynomial. Yes or no? So factorial 6 into 11. What is meant by factorial 6? Factorial 6 means 6 into 5 into 4 into 3 into 2 into 1. Yes or no? Hope it is yes. Now, next, how to proceed? You see, you observe carefully. We are not getting the product of consecutive term. So 11, 6 into 2 is 12. No, 11. 1 minute. 10. 11. The term 11 is still there. That's why n minus 2 minus 6. N minus 4 and denominator part is just permutation. You also observe how to simplify it. N minus 2, what is the question? N minus 2, n minus 2 P2. Did I write the question properly? Let's see. 11. It is 11. Then 5 into 2 is 10. 6, 5, 4, 3, 2, 1. Then, oh, yes, I can split 6. That's it. 6 means 3 into 2. See, 1, 3 and 6 means 3 into 2. So, 9. Okay. 11, 10, 9. Then 8. Got it. So, that factorial 6 and into 11 can be written also as the product of 4 consecutive natural numbers in descending order. You can ask me why. Factorial 6 into 11. Factorial 6 means what? 6, 5, 4, 3, 2, 1. With that, there is a term 11. 11 I kept separated. Then 6 is broken into 3 into 2 into 5, 4, 3, 2, 1. Now with 5 I multiply these 2. 11 into 10. With this 3 I can multiply this 3, 9. With this 4 I can multiply this thing 8, and at the end 1 is left. So like left hand side I have got same, you know, 4 consecutive number of products in descending order. So we can compare the like terms. You see, n plus 2 is 11, n plus 1 is 10, n is 9, n minus 1 is 8. By the number system, if you get 4 consecutive number of terms in algebra in left hand side and same 4 consecutive number in same order in numerical in right hand side, we can compare. N plus 2 is equal to 11, n is 9. Once you get n is 9, You see, this will satisfy which equation? Does it satisfy this? 9 square plus 9? No. 9 square is 81. 2 into 9, 18. No, it is not satisfying. 9, 81 plus 27. Yes. Option C correct. Got it?